When the north pole of the sideways planet Uranus started facing the sun earlier this year, astronomers expected to see giant storms brewing. But what they actually saw was way less dramatic. It was so weird that one scientist compared it to watching a World War II battleship sail past without any of the cannons firing. And even weirder, these unexpected observations were actually the second weird thing to happen at Uranus's poles this year. So what's going on? Are we missing something about this sideways planet? Or is it entering some kind of strange climate shift that we just don't understand yet? Let's dive into the silent northern storms on today's episode of SCI Show Space. Every planet in the solar system has its own unique tilt. Like Earth's tilt is 23 degrees relative to the Sun. That means as Earth travels around the Sun, we experience seasons because our poles face the Sun more or less directly at different parts of the year. Well, except for Uranus. Uranus is so dramatically tilted that both of its poles have been facing the Sun for the entirety of this year, which is why astronomers were expecting big storms up there. To explain, let's go back to last year when Uranus reached its equinox. That's when the planet's equator was lined up perfectly with the Sun. Astronomers knew that 6 months later, in January 2022, Uranus's north pole would be pointing right at the Sun. And that meant the northern hemisphere would be experiencing summer for the first time since 2014. And while half the planet was plunged into darkness, the other half was in daylight for nearly 2 weeks each. This is a pretty big deal for planets like Uranus and Neptune, which don't have a solid surface to absorb heat from the Sun. Instead, their atmospheres absorb and re-emit the sunlight they receive. So it takes years for the heat to redistribute itself. The atmosphere of Uranus, which is mostly hydrogen, helium, and methane, can only transfer heat so fast. Methane actually blocks the wavelengths of light we can see, but absorbs heat in the infrared. So scientists can't actually see Uranus's atmosphere getting warmed by the Sun. They infer the temperature by measuring how fast the molecules are moving in the atmosphere. Faster molecules mean hotter temperatures, but the heat generated by the Sun doesn't spread evenly throughout the planet. As it makes its way through Uranus's atmosphere, it hits different atmospheric layers at different latitudes at different times of the year. So one side of the planet gets much warmer than the other side, and the jet streams that girdle the planet get supercharged, blasting around at over 900 kilometers per hour. Now all of this matters because Uranus has rings. They are intermediate in complexity. Saturn's rings are far more extensive, but Jupiter and Neptune also have rings. All of the major gas giants do, in fact, and those rings are made of ice particles. They range in size from miles wide down to microscopic grains of ice. And the rings themselves are opaque, spanning hundreds of kilometers across, but they are incredibly thin, only a few dozen meters thick. The rings themselves aren't what causes the storms. Instead, the storms interact with the rings. The supercharged winds blow chunks of ice out of the rings and into space, creating what's called a haze. In 1986, Voyager revealed that Uranus had these strange dark spots in its atmosphere. And we now know that they are huge, dark holes in the haze. So the storms blowing the haze away leave behind these dark scars on the side of the planet. We can track them to understand how the winds are moving and how the energy is flowing in Uranus' atmosphere. And when Voyager photographed Uranus back in 1986, it showed us that the South Pole had a dark spot, too. But when the North Pole faced the Sun for the first time in over a decade in 2014, no storm formed there. Scientists thought that maybe the storm at the North Pole had dissipated or changed form. But then in 2017, a new dark spot appeared at the North Pole. Now it's still there, which means that either the 2014 storm turned into this one or there was another storm that came along afterwards. And that one lasted until early 2022, just before the most recent equinox. So it seemed like Uranus was due for a new northern storm, but it didn't happen. Researchers could tell the atmosphere was warming up because the molecules were moving faster, but they weren't seeing any signs of a big storm forming, not at first. When the North Pole first started facing the sun in January, researchers used Hubble's cameras to look at Uranus every week and search for signs of a storm. For the first 3 months, though, the North Pole was deceptively calm, which isn't what they were expecting at all. At first, astronomers thought that maybe the storm was hiding. You see, storms on Uranus and Neptune are harder to spot than they are on Earth because the planets don't have solid surfaces. A hurricane on Earth is easy to spot because we can watch as it churns up the ocean. But for Uranus, we can't actually see what's happening beneath the clouds. There are deeper layers of clouds below the visible clouds, and a storm might be raging under there. But if the storm wasn't deep enough to punch through the visible clouds, astronomers wouldn't have been able to spot it. In fact, even after 5 months, there still wasn't any sign of a big storm. And then in June, researchers captured something strange, a sudden and unexpected burst of activity. Bands of clouds raced across the planet and then vanished. These features were visible for only days before being dispersed by Uranus's winds. Researchers counted a total of 14 bursts, which took them by surprise. And one astronomer described it as watching a World War II battleship sail past without firing any of its cannons. And then in July, another strange event happened. A bright white cloud suddenly appeared in the stratosphere, high above the main cloud deck, where it stayed for about 2 weeks before dispersing. It's unclear if these events are related, but it's also unclear what caused them. Researchers have a couple ideas. Maybe there was a heat wave that caused the stratospheric cloud, or maybe the whole event was caused by the same phenomenon that created the mysterious bright spots seen in Neptune's stratosphere. Those bright spots have puzzled astronomers since Neptune's discovery. And we don't have any good ideas about what they are, although we think they have something to do with temperature inversions in Neptune's atmosphere. For now, though, the most likely explanation for the July event is that it's just a stratospheric cloud, something that has probably happened before and will probably happen again. The July event didn't require any energy from the lower atmosphere, unlike the strange bursts that happened in June, but in the end, we don't really know. The bottom line is that we haven't seen anything like this before, and that has some scientists worried. Maybe the storm did turn into something else, like a stratospheric cloud that we'll never see again. Maybe the storm dissipated and we just haven't noticed a new one forming yet. Or maybe there's something else going on entirely. Like maybe there's some kind of feedback loop happening between Uranus's rings and its atmosphere that we just don't understand yet. And all of this highlights just how little we actually know about Uranus. We haven't even seen the South Pole during the southern summer yet because it hasn't pointed towards the sun yet. So we don't know what kind of storm is gonna form down there. And if we can't predict what's happening on one side of the planet, we can't claim to understand Uranus's climate yet. We need more data, and luckily, we'll get it. NASA's launching the first mission to Uranus since Voyager back in 1986. The mission is expected to launch in the mid-2030s and reach Uranus in the early 2040s, and by then, we'll have observed the entire planet in real time for the first time ever. We'll finally be able to see what's going on underneath the clouds. And we'll have a whole host of new tools that we can use to study Uranus. This mission is going to change everything we know about this sideways planet. And we won't have to wait another 30 years to get the next batch of data. Thanks for watching this episode of SCI Show Space, which was brought to you by our incredible community of patrons. If you'd like to support SCI Show Space and all of our great educational content, you can head over to our support page to learn more.